Hello, and welcome back to Ninox Learning. In our last class, we took a look at the different kinds of Ninox tables and the different relationships between those tables. Master and parent tables, parent-child tables. We looked at links inside of families and across multiple families and stacks of data. In this class, we're going to take a look at linking master tables, those relationships between tables in different families, different stacks of information where we have an outer join, a link that goes outside of one family and over to another. Now I'm going to go ahead and move out of the way so you can see the screen. And as we usually do, we're going to start with a blank, empty Ninox database. And let's create two tables. Now for this example, I'm going to pretend that we're working with a financial system, specifically a general ledger and journal entry system. So we're going to create one table, which is going to be our chart of accounts. And we'll create two fields. Account number and account name. And of course, follow along on your own computer if you'd like to practice building these relationships as I do it here in the class. And our second field, account name. That'll work for table number one. Now, excuse me, for table number two, we're going to create a transactions table, specifically our journal entries table. We'll have an entry date, an entry amount, and then we're going to need a field for the account where we want to post the transaction. We'll get to that in a moment. Let's go ahead and save these changes and look at our data model for these two tables. Pretty simple stuff. We've got two separate stacks or two separate families of data. We have our chart of accounts here. We have the journal entries here. Now before we go any further, we're going to need to put a little bit of content in these tables. So let's go ahead and do that real quickly. Let's create 4 new accounts. Account 1001 will be our savings account. 1002 will be checking for payables. 1003 will be checking for payroll. And finally, account 1004, this will be our petty cash account. 4 accounts, each with an account number and an account name. Now, what we need to be able to do is go into the journal entry table where our transactions, where all of our business transactions are recorded, and refer back to the chart of accounts. So we know how to categorize each transaction. When we talk about links or references or joins, what we really are talking about is looking up something. Now, in the real world, and again, as we've talked about in previous classes, we build data models, which are models of real-world process flow, activity, operating procedure. The process that we are modeling here is the process of looking something up. The idea is, I don't know something. I don't have content or information that I need. So I need to go to another source because it's not in my own head. It's not in my internal source. It's not contained within me. So I need to go outside. I need to go to another source of content and get the information that I don't have. Think of it another way. There are 2 tables in a link. The table where the link begins and the table where the link ends. The table where the link begins is the table that is asking a question. And the table where the link ends, or what we call the source table, that is the table that answers the question. So let's think about it in the context of this data model. We have 2 tables, journal entries where we track our transactions, and the chart of accounts, where we manage all the different accounts in our general ledger that helps us organize those transactions in a meaningful way so we can produce financial statements, trial balances, things like that. Now, when we go into the journal entry table to enter a transaction, the journal entry table asks, what account am I going to post this transaction to? I don't know. I don't have that information inside of me, inside of this table. Since the journal entry table does not know, it's asking a question. The answer to the question resides in the chart of accounts table. The journal entry table reaches out to the chart of accounts table to get the account to which each transaction should be posted. So let's go ahead and build that link. Let's build the model, the data model of that relationship. The first thing to understand when you're linking master tables, when you're linking tables that are across different stacks or families, is that you always start with the table that is asking the question. We start with the table that needs the info, and the link ends with the table that is the source of that info, that information. So in this case, the journal entry table is the table that is asking the question, the table that needs to know what GL account is the account to which I should post this particular transaction. Now, we're going to go ahead and bring up our table management window where we do our data modeling. And we have our three panels. On the left, we have all of our properties. In the middle, we have the list of objects, fields, and layout elements that are the model, that are the components or the objects that make up the table. On the right-hand side, we have three libraries. These are the three buckets or containers, if you will, that contain all the different kinds of objects that we can use to build the data model for, in this case, the journal entries table. Now, you heard me just say there are three different types of objects. The default object, and the one that we're most familiar with, is the field objects. All of these different items here are different kinds of field, different kinds of containers that will hold specific kinds of content. Text, formatted text, yes, no's, numbers, currencies, dates, and times. The second type of object is the layout element. Headers and free text, buttons and spaces. We'll talk more about those when we start building user interfaces. But for this class, the layout object, the layout element that I most want to access are the table references, the third tab on the right-hand side of our table management window. Now, when you open up this tab, you will see all of the tables listed in alphabetical order according to the table name that exist within this database. In this case, we have two, the chart of accounts and the journal entries. Chart of accounts is listed first, not because it's the first table I created, but because it begins with the letter C, and C precedes J for journal entries in the alphabet. Again, always listed alphabetically. And when you start building more complex databases that might have dozens and dozens of tables, and you have to scroll to find the specific table that you're using to or from a reference, it's important to remember that these are listed alphabetically by name. So take that into consideration as you begin building out the architecture, the data schema or the data model, the tables for your databases. But back to the topic at hand, linking tables. As I mentioned, the relationship, the link begins in the table asking the question. The journal entry table wants to know, what account do I use? The answer is in the chart of accounts table. I grab, click and hold, the chart of accounts table and drag it over into the center section, the fields column. Now, it is very important to understand that a table reference, a link, is simply another type of field in the database, in the table. Just like we have date fields that store a specific kind of information, and time and number and text fields, each one that behaves a little bit differently because it's designed to store a specific kind of information, a table reference object is a field like all the other fields, and like those other fields, it behaves differently. And the unique behavior of the reference field is that it gets its information not from a user that enters it, not from a formula that Ninox calculates it. Reference fields get their information from other tables. Think of this as a pipeline or a conduit. The question flows out of the journal entry table. What account do I need? And then it flows back. The answer comes back. This is the account you're going to use for this transaction. Now, as is the case with all fields in Ninox, for that matter, all objects, layout elements included, we can rename each object. So I am going to rename this field that right now says chart of accounts, which is the name of the table that contains the information we're asking for. I'm simply going to rename it distribution account and accept that. I'm going to save the changes because, as I always like to say, save early, save often. You don't want to lose your data. Let's go back into table management and now look at the schema, the data model for this, the journal entries table. Now 3 fields, a date field, a number field, which I'm going to go ahead and rename transaction amount. And while I'm at it, we'll just go ahead and rename the date field transaction date. TRX is the abbreviation for transaction. And I've already renamed this field. Now, as you are used to doing, when you click on a field, it will bring up the properties of those fields, and it will tell you at the very top, in the middle of the top line of the properties window, the kind of field that it is. The transaction date field is a date field. The transaction amount field is a number field. The distribution account field is a reference. It is a reach out of one table, in this case, the journal entry table. Note at the top it says, from journal entries to chart of accounts. This is a reference from this table to another table, and it is in that other table where the content exists that this table, the journal entry table, needs. You will also see this reference, N:1. What this means is there are a number of transactions that can refer back to one account. We might have numerous journal entry transactions, hundreds, thousands, but we only have 4 general ledger accounts. Perfectly fine. This is a many-to-one. Many transactions can be linked back to one account, or conversely, one account can have many transactions posted to it. To put this in a different context, one customer might have many invoices. We have 2 tables in this example, the invoice table and the customer table. The invoice table asks the question, who is the customer buying the stuff detailed on this invoice? The answer is in the customer table, so we have a link that starts at the invoice table, reaches out and ends at the customer table, and that is an N:1. A number of or many invoices can be attributed to one customer. Many ingredients in one recipe. Many cars in one parking lot. Many employees working for one company. Many time cards or paychecks for one employee. These many-to-one relationships are the most common relationships, and the N is always the from table. many journal entries to the one account in the chart of accounts. Let's go ahead and see how this works in action. As I always like to do, let's go ahead and just do a little quick cleanup so this will look just a little bit better. Okay, and again, we save those changes. The transaction date, we know this is a smart field. It gives us our picker. We'll go ahead and pick a date. Transaction amount, 1,500. And the question is always 1,500 what? There are multiple currencies supported in Ninox. I'm simply going to format this with 2 decimal points and the comma separator between the 1,000 points. I will not specify a currency. And then we come to this, the third field, that very special field that is the link. 2 things can happen in this field. Now, you've heard me say it many, many times. In Ninox, what you need to know is what you want Ninox to do. Ninox knows how to do it. Ninox almost can predict what you need next, and it serves it up to you without you even asking. So the question is this: what is the account to which we will distribute this 1,500 unit, let's say dollars, this $1,500 transaction that was affected on April 2nd? What is the account? When we click on it the first time, there's nothing here. It knows to look, it being Ninox, knows to look up the information. Let's say I want to post this to my payroll checking account. Now, if I click on that same field a second time, it knows, because it already has content, not to look up a list of all of the records, all of the accounts in the general ledger, but to in fact give me specific information about the particular account that was previously chosen. Click on the same field again, it will behave very differently. It will pop up all of the information about the specific field that was selected. Now, you've heard me use the concept link when referring to relationships. Think of a chain link. One link linked, connected to the other, and they connect and connect and connect to form that chain. How do you break a chain? By breaking the link. This is the link in Ninox. This icon that kind of looks like a crazy 8 leaning over to one side. If I click on this link icon, the unlink icon, what this is saying is there currently is a relationship between these 2 tables, the journal entry table and the chart of accounts table. They are linked together. If I click on this, the link is broken. We go back to having an empty table that allows us to either look up and select from a field that is already there, or if we click the plus sign, to create a new account record. Let's say, for example, we want account 1005, which is petty cash number 2. We see now the 3 functions that all exist and happen automatically within a Ninox lookup or a Ninox reference field. And they are to look up, pop up a window of the existing content of the field where the link ends, or to, once data has been selected, once content has been put into the field, clicking again on the content will bring up all the details of that field. And finally, if we don't want to do either, we don't want to select an account that already exists, and we have nothing to look up, we can click the plus sign and create the record that we want. And you saw a moment ago that I created the second petty cash field. Let's look at a couple of other things that were created when we created this link. When you create a link, as you well know, you are creating a relationship from one table to another. We see the results of that relationship in the data model here in the journal entry table, the table asking the question. And here it is, the single object with the rightward pointing arrow, the arrow pointing in. This arrow pointing to the right, or this incoming arrow, is Ninox's way of saying the content of this field will come in from someplace else. And if we click on the field, it will tell us where that someplace else is. It's the chart of accounts table. An inward pointing arrow, an arrow pointing to the right, means that this is content coming into this table from another. Just like the little calendar tells us that this is date content, and the numbers tell us this is numeric content, the inward pointing arrow says this is content sourced from another table, not entered by the user, not calculated as the result of a formula. But there are two sides to this link. This is the information coming into the table. What about the table that the information is coming out of? Let's go take a look. In the chart of accounts table, we created two fields, the account number field and the account name field. Ninox created the ID field for us. Yet when I bring up the table management window, the edit fields window for the chart of accounts, I see three objects. The account number and account name field that I created just a moment ago, and this new field that was created by virtue of the relationship. Something that comes in to one table must come out of another. A moment ago, we saw a rightward pointing arrow, an arrow coming in to the journal entries table. This was a field, an object in the journal entries data model or schema that consisted of content coming in from some outside table, a table outside the family, a different stack. Here's the other side of that link, the other side of that relationship. The left pointing arrow, the arrow pointing out, says this object in this table is a reference from the chart of accounts out to the journal entry table. A moment ago, we saw an arrow pointing to the right that said this is information coming in from someplace else. Now we see the arrow pointing to the left that says this is content going out to someplace else. A moment ago, we saw a reference to the chart of accounts from journal entries that was an n-to-1, a many-to-one relationship. Well, if it's a many-to-one on one side, it must be a one-to-many on the other, and sure enough it is. Remember, here in the journal entries table, we see a relationship that is numerous n journal entries related to a single one record in the chart of accounts. The other side of that transaction is here. It is one record from the chart of accounts will be linked or can be linked to many or numerous journal entries in the other table, in the other family, in that other data stack. It is important to recognize that when you create a link in one table, you are creating a link in the other table. Now, of course, when we create a link in the journal entry field, in the journal entry table, we wanted to see the results of this link. On the 2nd of April, I transacted a $1,500 transaction, and I want it posted to my checking the payroll account 1003. It makes sense that I want to see that. But remember, for everything that happens on one side of the relationship, there must be, and there is going to be, another thing happening on the other side. Let's go to the other side of the relationship and see what's happening. Here is the graphic representation of the outgoing information here in the chart of accounts. And remember, this is the many listing. Let me show you what I mean. I will go back to journal entries, and I will create 3 more transactions. On the 3rd, there was another $1,000 transaction to that account. And on the 4th, yet another $500 was moved out of the checking account. 1 journal entry, 1 account. On the other side, 1 account, multiple journal entries. 1 to many on the front side, many to 1 on the back side. Now, I also want you to note how Ninox is presenting the content in these very special fields, these link or reference fields. Let's, as we have throughout this class, begin with the table where the link or the relationship begins, the journal entry table. What is happening is it is extracting, it is bringing back all of the content, all of the fields in the general ledger chart of accounts table. I only want to see one thing. I simply want to see the name of the account to which this transaction is to be posted. So if I go into administrative mode with my wrench, bring up the properties for this reference field, and go into more options, I find the show as property. This is a different kind of mask. Now you remember masks. Masks allow us to change the way something appears without actually changing what it is. Let's look at some common masks. Here in this numeric field, we can mask it as British pound sterling. We can mask it as a percent with digits on both the left and the right side of the cipher, the decimal point. We can even format it as 0 digits, no formatting at all, just the plain raw content 500. A mask is something that changes the appearance of the contents of the field without changing the actual contents. We can mask all different kinds of objects, and of course we can mask linked or relationships, references between tables. The mask here, however, is the show as field. When we go into show as, this will open up our formula or code editor. And I'm going to show you how to use both of the editors, the visual as well as the text editor, to define the mask for these reference tables. In this case, I want the journal entry table to reach out to the general ledger table, get the information for the particular account selected, and bring it back, but I only want to see the account name. In the visual properties or the visual editor, I'll grab the account name with a click and a hold, drag it into my formula field, click OK, and OK once again, and there it is. While all of the information is coming back from the general ledger chart of accounts table, only the one piece, the one masking component that I want to see, the account name, is visible. Let me expand on this just a little bit. Let's say that in addition to account number and account name and the aforementioned outgoing reference, we also have a field to track account type. Is it a debit or a credit account? Is it an asset or a liability or an equity account? So let's have account type. And let's have, these probably should be choice fields, but it's okay. Let's have standard balance. Is it a debit account or is it a credit account? And finally, which financial statement does it appear on? The balance sheet or the profit and loss, the income statement. I add all these fields. This account type is an asset. The standard balance is a debit. The financial statement is the balance sheet. Now, if I go back to the reference field in the table asking the question, the journal entries table, and I remove the mask, I see everything that was brought back in the order in which it is stored. The first field in the journal entry, in the chart of accounts table, is the number, followed by the name, followed by the type of account, the type of balance, and the financial statement. It went out and grabbed all that data and it brought it back. And since we have not defined a mask to affect the appearance of what was brought back, it is showing us everything. Now, since we don't need to see everything, we put the mask back in place. Select the field, go into the properties, show as is how we define what we want to see as a result of the extraction of information from another table. And in this case, all I want to see is the account name, and you see the effect of the mask. It limits my view of what came in from the other table, in this case the chart of accounts table, to only the field that is a component of the mask, that is part of the show as formula. Now, as you know, with formulas, you can get pretty fancy. So not only can you use the formula editor in Linux to control the mask, to control the appearance of the contents of the reference field, you can get pretty fancy. Let me show you what I mean. I promised I'd show you both editors. So for this example, I'm going to leave the visual editor and go into the text editor, and we're going to get a little fancy. We're going to do a little basic concatenation. We're going to add text components together. We're not going to add numbers. We're going to add characters. The first set of characters is the name of the account. When we add, we use the plus sign. So we will add a space in a left parenthesis. We will add to that the account number, and to that we will add the right-hand parenthesis. And lo and behold, that is how it is now presented, because that is how it is masked. You saw a moment ago that if we have no mask, Linux will present all of the fields of data from the table that supplies the content, the data, in the reference field. And we also know that it presents that content in order, with the first field first, then the last field last. We know that the field account number is the first field in the table. Account name is second. But here we've been able to reverse the presentation order and clean it up a little bit with these opening and closing parentheses by virtue of this concatenation formula. And we can get even fancier still. We may want to designate account name plus the account number with the field label, if you will, account number and a colon. That mask presents the content looking like that. Maybe we want to clean it up even a little more, and we want a space after the colon and immediately prior to the account number, and there it is. We're going to get more in depth in programming as we get into the 400 level classes, the next series of classes here in the Linux Learning Series. But again, what I want you to understand is these formulas, whether they are constructed via the visual editor or the text editor, give you complete and total control over the visual appearance, the masked appearance of the contents of these very special fields called reference fields. Now, of course, what you do on one side, you got to be able to do on the other. We have masked the single piece of content, the content related to the account number 1003, the checking payroll account. Let's go to the other side of the link and see how we can mask or affect the visual presentation of that side of this relationship between the two master tables. Okay, here's all of our content. I'm very quickly going to clean things up a little bit by making these fields a little bit smaller, getting these 5 text fields all up together, because I want to focus on this now 6th field, the one field I didn't create by going in and building out an object in the schema of the chart of accounts table. No, this journal entries field here was created by Ninox as the other side of the link relationship between the two tables. Previously, just a moment ago, we saw one field with one group of content, all of the content for the one general ledger account selected. Here we see the many side of the relationship. 3 transactions on 3 different dates for 3 different amounts, $1,500, $1,000, and $500, all presented in one single element, which we call a multi-listing or an embedded listing or an embedded table element. Like every other object in a table and every other object in form view, we've got tremendous control over the user interface, the visual appearance of this object. While still in administrative mode, with the red wrench in our hand, if you will, let's go ahead and select this object, this field, grab the sizing box on the right, and pull it back so it's just about there, just as wide as all of the 5 fields above it. Now let's look at the properties. A moment ago, we controlled the mask, the appearance of all of the fields for the one account record in the journal entry screen by masking those fields. Well, here we have to do it slightly differently because we're not masking all of the fields from one record. We're masking multiple fields from many records. Remember that many journal entries are linked to this one account. Our masking agent, our masking option here on the many side is the Edit Columns button right down here. Click on Edit Columns and it will present 2 sections in the window. The columns we can see and the columns that are available for us to see. What would we like to see about the transactions that are linked back to this account? We want to see the date, the amount, the account number, and the account name. And in fact, I want to see the date first, the name second, the number third, the transaction amount fourth, farthest to the right. Notice how I pulled. I'm going to cancel and do this again slowly. Notice how I pulled from the list of available objects on the right and pulled and placed those objects as visible columns in the left. 2 fields are native to the journal entries table, and this is the table that is supplying the contents of this multi-record listing. Transaction date and transaction amount are fields native to that table. The other content in the journal entries table came from someplace else. That someplace else is the chart of accounts table, which is the source of content to the field named distribution account. Open up the contents of that, and we see all of the contents that exist in the linked table, the general ledger chart of accounts table, which brings me back to something, a concept that I believe we introduced in the previous class. When any member of a data family or a stack has a link to any other member of another family, all of the members of both families have that relationship. I will cancel and do it yet a third time. Of course, we use our native fields of transaction date and amount. We only linked one field, the account number field. But by virtue of that link, all of the fields in the chart of accounts table are available to us to be presented on the many side of the relationship. I want the account number. I want the account name. I can grab all of them if I want. Account type and standard balance. I'll leave the financial statement alone. We click OK and OK again, and sure enough, when we save our changes, there it is. Each of the fields I selected, in order left to right as I selected them, the date, the amount, the account number, the name, the account type, and the balance. I want to clean this up just a little bit. The truth is, I don't need standard balance. I can hide that. I don't need account type. I can hide that. I'm only hiding it from this particular view. I'm removing it as a part of the mask of this field. I am not removing the field from the table. Of the 4 fields that are left, I want date first, account number second, account name third. And let's click and dive a little bit deeper. Let's click on the account number to bring up the properties for that component of my mask. And let's specify that I want to count the number of records by virtue of the account number that are in the table. And while I'm at it, I want this table sorted with the newest transactions on top and the oldest transactions on the bottom. So I'll go into transaction date, pull up those properties, and change from the sort order ascending to descending, from highest to lowest, from newest to oldest. Click OK, and OK again, and OK a third time, and there's our changes. 3 fields were removed. The 4 fields that remain now appear in the order that I selected. The date fields have the newest transactions on top, the oldest on the bottom. The account name, same account, so it has the same name. The account number, I wanted to count the number of entries in that column, so I knew how many transactions there were. And in this case, there's 3. And finally, it probably makes the most amount of sense to know what's the sum total of those 3 transactions. You don't even need to go into the element or the field properties. Simply click on the heading of the column, in this case, transaction amount, select, in this case, the mathematic manipulation, in this case, sum or additive total, and there we go. 500 and 1,000 and 1,500 are most certainly, when summed together, a sum total of 3,000. The Greek letter sigma being the numeric mathematical symbol for summation or additive total. In common best practices for user interface, you put your counts on the far left. So I'll simply count the number of dates. It's still same 3 because there's still only 3 records. Here's my count. Here's all my content. Here's my sum total. If I want, I could ask what's the average of these 3 transactions, and by going in and removing the sum manipulation and selecting the average manipulation, here we have the Greek symbol theta, which is the mathematics symbol for average, and here we see 1,000, which is indeed the average of 3 components containing 500, 1,000, and 1,500 units. 3,000 divided by 3, the average of 1,000. We can do mins and maxes first and last. Your heart can go crazy. The point of this is, by building the relationship, on the one side, we see all of the table about the one record that is linked to the journal entry. And on the other side, the many side, we see the many journal entries that are linked to this one account. Now, let's continue. In this example so far, we've created a single link, and we see it now here in the data model between this table, the journal entries, which is reaching out to the chart of accounts table to get information it needs but doesn't have. We've seen that link manifest or present itself in the one form of the journal entry field here, distribution account, and the many field, journal entries, here on the account itself. And it makes sense that we want to see those. We want to see what account the journal entry is distributed to. We want to see what transaction distributions are associated with each account. Let us now look at two capabilities of Ninox. One that we may want to use and one that we probably don't want to use. The truth of the matter is, when you're doing journal entries in an accounting system, if you're following the recommended standards of double entry accounting, you have not one distribution account, but two, a debit and a credit account. Therefore, we need a second account that behaves exactly like the first one, that allows us to understand what is the other side of the transaction, the two sides being the debit side and the credit side. Let's go back into table management mode, if you will, and let's change the heading of the distribution account to be the debit account. The feature that you're going to want to use sometimes is the ability to have multiple links between the same two tables. We have one field, the debit account field, that is a special kind of field, a reference field, that gets its contents from the chart of accounts. We need a second field just like it. We build it the same way we built the first. Go into that third set of options for table objects, grab a reference from chart of accounts, rename it the credit account, and save our changes. Clean up our screen a little bit, and there we go. So for this particular transaction, if we wanted to take money out of savings and put it into checking, there's the two accounts, the date and the amount of the transaction, and there we have it. Now, watch this. If we go back into the chart of accounts, if we look at the payroll account, we see, of course, the three transactions. If we look at our savings account, we see that other transaction. We built a new link. We have a new relationship. That double link, that twin relationship of two accounts in the journal entries table, two fields in the journal entry table, both getting their content from the one chart of accounts table, is represented by these two arrows. Two tables, one table asking the same question twice. Which account, which account? Which debit account, which credit account? However, on this side, we have the incoming content. Note the rightward pointing arrow. Data coming in that answers the question, what's the debit account? Data coming in that answers the question, what's the credit account? However, on the other side, here's the thing you probably don't want to use. Because there are two links in the one table, journal entries, there have to be two links on the other side. And we don't need to see them both. This is a duplicate link. Any transaction that exists in the journal entries table that is linked to account 1001, we only need to see it one time. But because there are two links, it is showing us both of those many links. I only need to see it once. Therefore, I'm going to kind of undo something Ninox did for me automatically. It automatically created the second link, and I don't need to see it. So I'm going to go into the properties, and under display field only if, I'm going to say null, which in this context means never. I never need to see this field. I just need to see all of the transactions linked to this account one time. I do not need to see it a second time, therefore I have nulled out. I have made it such that this field will never be displayed. The field most certainly still exists in the table, This is the debit transaction account in the journal entry table. And this is the, sorry about that, little cutting and pasting. This is the credit transaction account in the journal entry table. I need to see both fields over in journal entries, but here I only need to see one, so I use display field only if null. Never display it a second time. Only need to see it once. We save the changes, exit administrative mode, and we very quickly build a nice, simple database. I can go into my journal entries, and I can create transactions. For example, I might want to move $1,500 into petty cash by taking it out of my payables account, and there we go. I enter it. There's the transaction. I go look at the chart of accounts. Here is the payroll account. Here is the petty cash account. There's the second petty cash account. And here is the $1,500 transaction you just saw me effect. Let us continue to the final aspect of these relationships. And that final aspect is our ability to use other fields in the source table inside of the table that reached out to get the information. In this case, the journal entries table. Let me show you what I mean. Here we see the two relationships. I'm going to get rid of these fields for just a moment. Pardon me while I do a little housekeeping. Okay, there we go. Now, here we have our debit account and our credit account. Two objects, two fields in the journal entry table that get their content from the one chart of accounts table. Each of these fields has a current balance. Let's go into the chart of accounts table real quickly and set up a field. We'll make this a numeric field and we'll call it current balance. And let's just say for purposes of this presentation, the current balance in petty cash is $2,500 and the current balance, and I'll go ahead and display those current balances. The current balance in savings is $1,000. The current balance here is $2,500, and I'm just scrolling using the record control arrows to go to the next record in the table. In this case, record 1003, and let's say that has a $750 balance. And finally, petty cash number 1 has a $1,000 balance. Now, here are all of our accounts. Number, name, balance. Here is the journal entry table. It has two references out to that chart of accounts table. We have masked these reference fields to show first the account name, then the account number with this label concatenated in and enclosed in parentheses. What if I also want to view the current balance of this field, but I do not want it to actually be concatenated or embedded in the field? I want it in a separate field with its own label. We can do that with a very simple formula. Let me show you what we do. I'm going to quickly create a space just so I have a nice clean looking field to work with. And instead of grabbing a field object, I'm going to grab a formula from my toolbox on the left-hand side. The formula is, in this case, the current balance of the debit account. And I will call this field current balance, and there it is. Now let's say the credit account for this transaction is, in fact, payables, and I want to see the current balance for that account also. Another formula. I drill down into the credit balance link and grab the current balance for the credit account, which in this case happens to be $2,500. Save it and name it current balance. And let's go ahead and save what we've done, except we have a problem. No two objects in any single table in Linux may have the same name. This is considered an ambiguous naming convention. This is an ambiguous field error. We have two fields, in this case formula fields, both named current balance. That is an ambiguous error, not allowed. Let's name this one current debit account balance, and let's call this one current credit account balance. Save our changes, exit administrative mode. The save worked because we took care of that ambiguous naming error. So let's review a little bit of what we've seen. We created a relationship, a link, between two tables. The link or the relationship originated in the table that needed content, needed information. And in this case, that is the journal entries table. The information it needed existed in the chart of accounts table. So in building the schema or the data model of those two tables, we started with the table asking the question, the journal entries table, and in table management mode, dragged over a table reference, not once, but twice, as one of the field objects in the schema for journal entries. While both of these are the same type of field, a reference from journal entries out to chart of accounts, they are two different fields, so we gave them two different names: debit account and credit account. Now, this is the one side of the one-to-many relationship. On the other side, the chart of accounts side, we see the many. Here are the many transactions associated with this account. And as we scroll through the accounts, it shows us which accounts have transactions. This account has 1. These accounts have none. This account has 3. We then were able to use some of the built-in Linux formulas, like the ability to count the number of records in a many record listing, the ability to change the presentation order from ascending to descending, the ability to perform mathematical and statistical manipulations like sum and average, min or max. All of these functions are built automatically into Linux. They require no coding. Again, you only need to know what you want. Linux knows how to give it to you. If you want the total of the numbers in this column, click on the column and say, give me the sum total, and Linux does the rest instantaneously. Finally, we talked about that idea that sometimes we want to see everything, sometimes we don't. Remember, back here on the other side of this link, there are two. There are two links coming over to the chart of accounts table, and here we see them. The debit transaction account, the information going out to the first account in the journal entry table, and another link supplying the content for a second account. Both of the links exist, but we nulled out the appearance of one because we really only needed to see it one time. One time on the many side, many times or both times on the one side. It can be a little confusing, but if you have questions, click on the field and look at the information Linux is giving you. And that information, the explanation of the field, will always be at the top. This is an incoming reference, incoming being indicated by the rightward pointing arrow. It is an incoming reference from the journal entry table to the chart of accounts table. It originates at journal entries. It goes from journal entries out to chart of accounts, brings back all of the chart of account data, masks it or edits its appearance according to this formula, which can be produced by typing it in, dragging it from our option palette on the left, or using the visual formula editor and dragging it from our table options or our field options at the bottom. And finally, we created two formulas in the journal entry table, where the formulas are actually content coming from the other table. Here we see that the content of this field here in the journal entry table is actually coming from the chart of accounts. This is that link. So we started with the very simple idea that one table needed information that existed somewhere else. In this case, it was the journal entries table. It reached out and got that information through a master table to master table link, and the other table that was the other side of the link was the chart of accounts. Keep in mind some key facts. Two tables can have multiple links between them. In this case, the journal entry table reached out to the chart of accounts table not once, but twice. By virtue of those links, all of the fields in the chart of accounts table now are available to us automatically in producing formulas and calculatory algorithms embedded in the journal entries table. A relationship between any field in two tables is a relationship of all fields in both of those tables. And that is how we build relationships, outer join relationships, between two stacks or two families of data. In the next class, we're going to look at the next kind of relationship, the inner join. How do we build relationships between parent and child tables? That's the next class, and I sure hope you'll go check it out. Thanks for joining me here in the master table linking class. If you have questions, watch it again, or shoot me an email at andy@ninoxus.com. I'll see you in the classroom. Thanks for joining me.